The Dutch Groningen field is Europe's largest natural gas field, which has been a reliable source of energy and greater energy diversity across the Netherlands and Europe for 50 years. The field uses 29 production installations spread over the field in 14 king-size clusters and 15 standard-size clusters. As the volume of the gas had been depleted by as much as 50% in the 1960s, there was an immediate need to extend the reserves of the Groningen field. With free-flow production rapidly decreasing, NAM decided to bring all of the installations up to date by installing compressors, renovating the existing equipment, and adding a new process control system. The success of this project was a result of teamwork, technology, and long-term thinking by NAM GLT, Gasunie, Shell, ExxonMobil, and a consortium including Waukesha Magnetic Bearings. Henk Niesen, project director, and Wim de Groot, rotating equipment engineer of NAM GLT, share their experience working on the NAM project and their decision to implement a compression string using magnetic bearing systems provided by Waukesha Magnetic Bearings.
This field is so large that it can deliver for around 40 years gas for all the households here in the Netherlands, but also exports the gas to Germany and Belgium. It started initially with around 350 bars in the reservoir, and it has been declined over the years up to now to around, I would say, 100 bar. That means that this field, which has been built in the years 70s, has to be renovated fully. All the sites, which were 29 sites, had to be replaced by modern new technology, modern controls, and most important, compressors.
Traditionally, companies like NAM and Shell or ExxonMobil, who is our partner in NAM, are risk averse to these extents, but I would say for the magnetic bearing system in compression strings, this is no longer the case. This is now proven technology.
The NAM GLT contract is a good example of our ability to partner with the OEM's end users. In that instance, we work with NAM to sit together and determine what is required to make these machines work reliably over a long period of time.
Technology leadership is at the forefront of every Waukesha magnetic bearing system. The custom-engineered system for the NAM project is a good example of that.
The NAM GLT bearing system has magnetic bearings and auxiliary bearings of unprecedented size. You can see behind me the motor bearing for the NAM project. The magnetic bearing for this application is 550 millimeters in diameter, and the auxiliary bearing bore is 450 millimeters in diameter.
There are many advantages of installing a magnetic bearing system from Waukesha, including its software functionality, enabled by remote connectivity capabilities.
All our controllers are equipped with a web interface, and that means that so long as we have a suitable TCP/IP transport mechanism, that we can log into our systems remotely from anywhere in the world.
Waukesha Magnetic Bearings has achieved reliability and availability that is unmatched in the field.
If we look now at the reliability and compared with what we expected 15 years ago, it came out to be better, surprisingly better than we expected then. The reason for that is that, of course, we renovated the whole installation and all the controls, but also the performance of the compressor itself was so much better, and it has very good records. And it has to do with, partly of course, with the magnetic bearings and its own reliability, but also the simplicity of the whole design.
It meant that a lot of the traditional equipment that you have around the compression string, like lubrication systems and other oil systems, were no longer present, and because of that it would reduce the amount of auxiliary equipment around the compression string a lot.
The reliability is of most important thing, together of course with costs, because we have to deliver the gas on the moment that it is asked. If the operator pushes on the button to increase or to stop the flow, it must be done directly. And with such a huge system, mind you, 23 megawatt with 25 compressors in the field, which all had to operate simultaneously in this way.
Traditional compression train would have an average of 87% availability, and that is already high. And here we reach over 95, sometimes 96, 97%, with a reliability of over 99%, and that is very, very good for a compression spring.
With over 30 years of installations in the field, magnetic bearings prove to be the lowest cost solution over the life of turbo machines.
The total cost of ownership, the way that we call it to calculate it, looks at the efficiencies of the compressor, both at full load and low load. That means a 23 megawatt compressor will run maybe 70–80% of the time not be above 7 megawatts. That saves us a lot of energy. We made the calculations based on the amount of energy you save if you could run at part load over 25 years, and then you see immediately that it has an enormous impact on your costs.
A solution with magnetic bearings saved us a lot of investment cost, about 35% eventually, and on life cycle cost it was a tremendous amount of savings that we could make, all to the benefit of the combination where magnetic bearings played a key role in this whole setup.
I think it was very clear to Waukesha what our application was and how important a robust, reliable compressor would be for us. And I think they contribute together with Siemens to find for us the best solution.
I think that we only see the beginning of the technology and the capabilities of magnetic bearings. I think there is a whole future, bright future ahead of this new technology applied in equipment in the oil and gas industry.
Whatever you do, on the end, it's the performance that counts. And when I look at the performance, it's really amazing good. Yeah?